All right, good afternoon, folks. So we've only got three lectures left today, and then Thursday and next Tuesday. After that, we'll have I think our final time is I think on the 10th. So I'll talk a little bit about that today as well. But the main thing that I want to talk about with regards to sort of the upcoming stuff is some of what I put in the weekly email yesterday. You have the uh, the sort of game jam final project this weekend ish. So uh, Thursday after class, I'm going to make the sort of PDF sort of documentation of that available. So that'll give you sort of access to what the theme is going to be, and sort of a few other things, some suggestions of mine, and that sort of stuff. I want you to create a full sort of game, sort of in the vein of the ones that we've worked on in class. Uh, it doesn't have to be amazing graphics and all kinds of post processing and all that kind of stuff. I do want you to focus on things like features that feel good or work well. I'm not expecting a huge game with tons of features. Uh, think of it like a game jam style thing. The the game that I made for the most recent Let 'em Dare is a perfect example of that. Something that you could make in, for me, made it in sort of 48 hours, but of course it was less than that because I slept and did other things. So don't feel like you have to work the entire time to get something amazing out there. I do want a game design document as part of it, and also I'll talk about this a little bit more on Thursday. But it doesn't have to be as fleshed out as the other ones. I just want everybody in your group to have an idea of what you're going to do. Make sure that everybody is on the same page for what you want to make, and I recommend doing that. That's the first that'd be the first thing you do. In principle, you could do it on sort of Thursday afternoon, Thursday night, and then be ready to jump in on Friday and start coding stuff. So, whatever tools you've been using, so having something sort of ready on Git so everybody can work on stuff could be useful to do. If you've been using any organizational tools, or you've used organizational tools in the past, something like Trello, for instance, that could help as well with sort of getting everything done that needs to be done. So that's coming up over the course of the next 7 days or so, where you want to start thinking about this sort of stuff. If you want some inspiration on the scope of a project, or sort of a certain game style to go with, you can certainly check out some other game jams and entries other people have done for game jams. This is the first semester this class is running, so other than the game jam stuff that I've done in the past, I don't have anything sort of directly to show you. But if you hop on to Let 'em Dare, you can look at previous stuff. You can look at some of my previous stuff if you do a search for it, and just see sort of what people have done in that sort of limited time frame, and check out the graphics and check out the sounds and the music and stuff that people add in, because there's a lot of good ideas there. I am taking the theme to be one of the potential themes for a past Let 'em Dare. So at the end of the sort of theme selection process, there's like 10 or 12 themes usually that are sort of one of those is going to be chosen. I've taken one of those from a previous Let 'em Dare, and that'll be the one that you guys have to work with. The nice thing about sort of themes in that way is that it does give some direction. So rather than just being totally open-ended, make a game you want, it gives you something to try to focus a little bit more on, so it can help reduce the scope rather than being totally open. And it's fun to see what the different ways that people interpret stuff. So I think the final project here can be quite cool, even though it is sort of a more limited time frame to work on it. So we'll talk a bit more about that tomorrow before it sort of becomes available, and certainly over the weekend, over the time that you'll be working on it, you can definitely ask questions to each other on Slack. You can email me and sort of get things clarified, or sort of whatever you want to do. I'll certainly make myself as available as possible while you guys are working on this stuff. So today, I sort of slimmed this lecture down a little bit and made it just on the boss, because I want to talk about how we're going to get the boss to have a couple of different behaviors. So this means including, the code that we need for the boss, things, the standard stuff like the health and the movement speed and all that stuff, but also the two behaviors, the sort of ability to do the two behaviors that I'm intending. So I have this patrol behavior that we're going to program in, and I have a chase behavior. So after a certain point, so the boss will start in patrol. After a certain point, the boss will move to a chase behavior. And you can define that or define that change however you want to. I'm just going to define it based on the boss's health. But of course, it can be determined by how close the player is to the boss, for instance. So there's lots of ways you could sort of trigger a change in state. So the state machines that we've written before are very useful for this. There's not going to be a lot of code in the state machine, but the idea will be the same. We can literally take the state machines that we've written before, strip them down, and add in the sort of boss appropriate things. So the boss itself is just a regular enemy. So just like a ranged enemy, just like a melee enemy, it's the same thing. It's a regular enemy, but it's going to have a couple of different things in its concrete class. So we're going to have an AI movement. We have a rigid body. We have a health. We have that enemy action, or that kill enemy sort of action that we created before. So we'll have all of that stuff. Set target and get attack and take damage. We'll have all the normal stuff for that. But we're going to add a few extra things to it. And I want to point out a couple of the extra things here to start with. We're going to have an array of transforms. That's going to be our patrol points. That's going to be the locations that the boss is patrolling to. And we'll do some random thing with that. So it's just he moves to a random location, and then once he gets close to the random location or close enough, then he'll turn and go to a random different one. We have the boss state as well. So that'll be an object that we're going to use our state machine to create, and a couple of variables to help us out. These are particularly with the patrol. So the new point, do we need to choose a new patrol point, and the target index, which patrol point are we going to in the array. So a couple of variables to help us with the transforms and a boss state. The rest of it is relatively similar to what we've seen before. For take damage, I don't know if we actually needed that one, but I do have it overridden in here. And then get movement, of course, overridden in all of our enemies. And then a couple of private functions here that will deal with which movement do we want to actually get. Do we want to get the patrol movement, or do we want to do the chase movement? And that will be dependent on our specific state. So we're going to use this idea that the state variable appears to change class. So I mentioned this sort of previously when we first talked about the state machine, that it appears you're not like doing anything to our state variable, but it looks like it changes class when the state changes. So we're going to use that info to determine which of these movement functions we want to call, and ultimately what movement we want to do. Because the boss is a regular enemy, it's also an I product. So we can use the spawn manager to actually spawn it. So there's not a ton of code we have to add. We got to add the capability to spawn a boss and sort of when to spawn a boss. But there's not a ton we have to add a boss into our spawn manager. And if I made it so that our factory, our enemy factory, was a mono behavior rather than a regular class, then it would be just a matter of adding some more stuff into the inspector, dragging some more objects into the inspector, or prefab, something like that. So we'll do a little bit of this sort of pre-stuff first. And then we'll jump into what the boss state machine needs to look like, or sort of what we want it to look like, and then we'll go into the boss class. So I want to add a few things in code first. So I have the spawn manager open already, and we have a few prefabs that are sort of set up. There are enemy prefab for melee and ranged. Well, we're going to need another one of these because we need one for the boss. So we'll have a boss prefab here, and that's literally what I'm going to call it. I'm going to call it the boss prefab. So I need another one of those, and that's going to need to go into the enemy factory. Again, if the enemy factory was a mono behavior and we just added it, which is certainly something that you can do. If we just added it as a component to our game object, then we wouldn't have to do that. We would do stuff more in the inspector. But the way that we've coded this, we want the boss prefab to also go into the constructor. So right now there's an error here. We need to go change the enemy factory, but for now we're just going to leave that with the error. If we look at the rest of this for the spawner, we don't have to change anything. That's one of the beauty of that's one of the sort of beautiful pieces of using a factory like this, is that the boss is an enemy. So we're going to add it to the enemy list. We're going to put the remove enemy function into our action list that we run, and we're going to set the target to the player. That might not be what we want initially, but we might want to target the patrol points, for instance. But this sets everything up, and for a boss, it's not different. So this is a very useful thing to sort of code it in this way. We use a factory, I don't have to change the spawner. I just have to update the factory, and the spawner will do its thing. There is one thing that we should do. We could potentially do it here. I don't want the boss to be spawning with regular enemies. Like, I don't want him to spawn on like a regular wave. Like wave 1, I shouldn't see a boss, for instance. So we'll probably need some sort of wave counter or something. So that's something that we can look into either adding here or in the enemy factory itself. So I added the boss prefab. Let's go put this into the enemy factory itself. So for the constructor, I need another enemy. I'm just going to call it boss. And I need another private variable here for the boss prefab. And we'll set up boss prefab equals boss. All right, so now we have the boss prefab. We have a few things here for our spawning. We need to add one more for the boss. So we sort of think of this here as our sort of regular enemy spawning. We'll need something to do a boss spawn. Like this. Now, we don't want to spawn the boss every time. Here we sort of have a percentage chance of every enemy we spawn. I don't want the boss to spawn every time or have a chance to spawn every time. I only want it to spawn certain times. I had this current wave variable here. It starts at 0. So what I could do is I can use that variable. I can change it elsewhere. So I'm probably gonna put it back in our spawner. I'll have a way to change this this current wave. But I could say something like this. I could say if current wave, let's say mod 3. If that's 0, so if it's exactly divisible by 3, then let's return spawn boss prefab x, y. So if our current wave divisible by 3, then spawn a boss. So that is something that you can do to sort of limit it to only certain waves, get certain types of characters and stuff like that, certain types of enemies, things like that. I need a way to change this though, and I don't know if we put one in. I don't know. We didn't. So what I'm going to do is I'm just going to make a quick setter for this. So I'm going to say public void set wave, or maybe I can have like increment wave or something, inc wave. And so all it does is current wave plus plus. If you reset the game or something, you'd probably want a reset thing or something, or just a set wave to set it to 0. Whatever you want to sort of do for that. I'm not going to worry about resetting the wave. We'll just have it sort of continue to go up as we play. But again, if you die and you reset, you don't want the wave to be the same as it was before. So you'd probably want a reset wave in there somewhere as well. So we have the increment wave. So in our spawn manager, this is basically it for getting the boss in there. As long as we have the prefab, we send it into our simple spawn function, which is just a wrapper around instantiate. So back in my spawn manager, our enemy factory should be back to working correctly. After I spawn a wave, so we spawn the wave here and do all of the for loop stuff, then I can say factory dot inc wave. So the wave goes up and so on. Now, I haven't really taken into account this enemies per wave. If this value is set to 2 in the inspector, then I'm going to spawn 2 bosses. Probably not what you want. So you might need a little bit of extra logic in here to deal with on whatever, mod 3 wave. Use enemies per wave equals 1 or something. So you might need some extra logic in there. I'm just going to leave it as is, but some extra logic in there just to check what the wave currently is or something. So you might need a getter for the current wave or something. So there's a little bit of extra logic you need, but hopefully you can sort of see how this spawner can work with a boss. So you can use essentially the same spawner with a boss, increment the wave. The factory deals with what exactly spawns, so that you don't have to go mess around with the spawner, with the actual spawning code that much. You just have to mess around with the factory code, and then you're pretty much good to go. So something like this, I think will work fine. And if not, then we will see. We will get some sort of error with it. But I think this is pretty much the setup that we need. Okay, so any questions about this so far, about this sort of setup for getting the boss to at least spawn and be in the correct places, right? Like it should be in the all enemies array. That's one of the big things it needs to be in, because that's how we move it, right? That's how, if we go to the game manager, we loop through all of the enemies in all enemy and run their move and get attacks. So we need to make sure that our boss is in that array. That's why in the future I won't just be able to put the boss directly into the into the scene and hope that it works properly, because it is an enemy that needs to be run using the entity action. All right, so let's go. I think the state machine next. Yep. So let's talk about the state machine a little bit. It's a simple state machine. There's not a whole lot going on. It's nearly identical to the game state machine, but it only controls the movement changes. So the actual movement, it's still handled by game state. So that's why we're calling entity action and all that stuff I just mentioned. So it's simple. In the patrol state, so the game starts. That's what my little black dot is here. The game starts, the enemy spawns, the boss spawns, and it'll be in the patrol state. So we're going to create a list of points, essentially just empty game objects, because empty game objects, even though we normally call them empty, they still have a transform. So it's going to move between an array of transforms. When it gets to half health or whatever other condition you can think of, then we're going to transform it to the chase state. In that case, it targets the player, and then we can change its speed. Maybe it moves at double the speed that it was moving between the patrol points or something. So very simple state machine. We're going to set that up here in just a second. But first, I do want to write the sort of outline, or at least most of the boss class, before we create the state machine part of it. So if you're working on the final project and you have a little bit of time and you have a state machine, or you have something that could use a diagram like this, they are super useful to understand what's going on. Because I think this with the little notes and the arrows and stuff is probably a little easier to understand than if I just wrote out a paragraph of text or something, or had a couple bullet points. This is probably just easier to understand overall. So if you do have a little bit of time, making a diagram like this can be quite useful. I use Plant UML for this, if I haven't mentioned that before. Okay, so we're into the boss class. I'm going to write just these first, and then we'll come back to the slides. So we'll get awake and update, and then we'll sort of talk about it, because I have a couple pop-ups here. So let's go and do that. So back in Unity, I'll let this compile here real quick, and then I'm going to create a new script, and I'm just going to call this. Let's see, we did the other ones. We called them like ranged enemy and melee enemy. So I'm going to call this boss enemy. And I know I mentioned this before. Some more organization here, once your scripts start to grow, is probably a very useful thing to do. I'm not going to, but it can be super useful when you get to be when you get to be dozens of scripts. It's useful to combine them together into different folders and stuff. Okay, so I'm going to write update, and I'm going to, instead of start, this is just going to be awake. So I'm awake here, and I'm going to first start with the variables. So we need that array, and this is just this is going to be public, because we're gonna add the transforms into the. I want that public. We'll make it public, and I'll show you a couple ways to deal with this. I think the code in the slides. I don't necessarily have to do it the way that I have it in the slides, but I'll show you a couple ways. So this will be a public transform array, and I'm just going to name it patrol points, and I'm going to set it to null to start with. So it's just going to be empty, but it'll be accessible in the constructor. We're going to have a few private variables, just sort of the standard ones. So we'll have a boss state for our state machine. We don't have this this type yet, so that's something we'll get to in the near future. I'm going to make a private bool called let's see, new point, and we'll start that as true. So this is just going to be if we need to select a new control point. So if we need to select a new one, let's say we got close enough to the one that we were moving towards. Now we need a new patrol point, so we need a new one. So this will trigger that condition to change patrol points. And then we'll make a private int, and this will be the patrol point we're moving to. So this is the target index, and we'll just give it a 0 to start with. And this is the current control point I'm moving to. And it's just an int because it's an index of our patrol points array. So the nice thing about having an array like this, and especially making it public, is that it can be super easy to add more patrol points. So you have a level or something that's bigger, maybe you want more patrol points than on a level that is smaller. So it makes it easy to adjust that for the boss on a particular level. Just like our other enemies, we do need to call base.awake, which means we're going to use, and I don't know if this was in the slides or not, we need to use the new void here. This should be, yes, we need to have this be an enemy. That needs to inherit from enemy. There we go. So just like our other ones, we say new, because this is, we don't want it to have an issue when we want it to run this one, and then we call base.awake. The constructor chaining type stuff and some of this chaining thing, because we don't have direct access to the constructors in a mono behavior. Some of that chaining stuff doesn't happen in sort of the normal way with these mono behaviors. So making this new and then calling the base one is what we have to do with this. In our state, we're going to set this equal to a new patrol. So we're going to start, and this we still have to write these, so that's why there's the error. And we're actually going to send in this. We're going to send in the boss. So our state takes this boss. You'll see why we do this when we write the actual state machine itself. So we're going to start out in a patrol state. We run the awake. Remember what awake does. If we go back to enemy here, awake will set the health to the max health, grab the rigid body, and grab the AI movement. So that's something we need to remember to add to the prefab for our boss. We need one of the AI movement components as well. So that's what base is doing, and then we're making a patrol state for the movement of this guy. Now I have in the slides, I have a patrol points thing that I set, and we don't have to do this. We're actually going to comment this out at first, and then I'll sort of show you what this does. I have this as sort of finding a game object that contains all the patrol points. So you can do like game object, find game objects with the tag, I think is the one I used. And then in here, and I'm going to show you how to do this. I'm basically going to stop when we do this. I'm going to add the patrol points in and show you sort of what this does. Find a game object with game objects. So the big thing here is to note the S, game objects with tag. And the tag is going to be patrol points. And then we're going to get components. Have another, should just be get components. Then it should be So that'll be the patrol points. And we got to get the components. We got to get the components in the children. I'm going to create this. I'm going to create this first anyway, because I don't know why I don't have a get the get components in children. Right. So I'm going to go into Unity and create this, so you can sort of see where I'm going with this. So in the hierarchy, I'm going to create an empty, and I'm going to name this patrol points. And I'm going to tag it with a new tag. And I already have the tag in here. I already have the tag created. But I would create a new tag called patrol points. And then I'm going to tag this with patrol points. Now, this is only one object. And so it's only one thing. But I can create a bunch of children underneath. So I'm going to create another empty as a child. And maybe this will be 0.1. I'll create another one. Create another one in here. And maybe this will be P2 or 0.2. Create another one, and I'll have 0.3. So I have sort of 3 patrol points to choose from. Now, all of these have transforms. I don't need to set their tag. And we are going to talk about why here in just a second. Why would I need to do that? Turn on the spotlight as well. What we're going to do is we're going to take these points here, and we're going to grab all 3 of those points in code. The reason we want to do that, and the reason why that should work the way we need it to, is that this is going to be on a prefab. So I need to have a way to set these patrol points in code rather than for the prefab itself. So we'll talk about that here in a second once we create, or once we add this to our enemy. Again, right now we have some errors. So if we want to, for now, we can comment out the error parts, the stuff with the state machine, and we can actually add this to our game object, and you'll sort of see what I mean by these patrol points and how we need to add stuff to them, and how we can add stuff to them. You should have a prefab already that is a dumb-looking boss prefab. And it should have the transform and the rigid body. So I'm going to add our boss enemy script. Remember, you get an error when you try to do this on an enemy. Can't add script behavior AI move. The script class can't be abstract. So I need to add my movement, my arrive movement, to the script first, and then I can add my boss enemy script, because we need that AI move because this is an enemy. So I'm gonna set a couple of these things. Maybe we want 1 for the radius and whatever, 1 for the time to target. Max health maybe is 10. Movement speed is 5. I don't know. Just throw a couple values in there. Then we have the patrol points. So this is my array down here. I don't know why the spotlight went away. This is my array right here, and we could set this to be size 3. And try to add these guys in. But notice, it's not letting me put it in there, because this is the prefab. This boss is the prefab. The patrol points here are not a prefab. I could make it a prefab and then start throwing stuff around. But if I don't want to make my patrol points specifically a prefab, then I need to do this in code. So there's a couple of ways that you can go about sort of adding this sort of stuff to your boss. So we just have the patrol points array. I'm going to leave it as empty in the prefab. That's where we're going to add here. That's how we're going to get this to go here. So we're going to find the game objects with tag, and try just game object. I don't know why I didn't have the get. Yeah. So it must be, so there's only one of these with this tag. So to get the components, we just need the game object, and we need to get, because remember, this is an array. So I need an array to come back from this. So we need to get components in children, and this will be the transform. components in children. This is where they usually add in the S in the various places, and it can get, if you don't remember which one to use in certain situations, it can cause problems. So find game object with tag, patrol points. So we are finding, come back here to Unity, we are finding this game object only, this patrol points game object. And what we're doing is we're getting the components with the S in children. So we're looking at all the children, point 1, 2, and 3, and we're grabbing each of their components, their transform components. So that's why we get an array back. Technically, and this is something you have to look up in the documentation, technically I get 4 transforms back by doing this. I get 4 transforms in this patrol points, because it's not just the children that I get the transforms from, it's also the original one. It's also the parent. I get the transform of the children and the parents going into this array. So that's how I can fill my array up. I look at the game object with tag, find that at top level game object, and then grab the components in children. So this is a relatively easy way to do it. Do not, under any circumstances, never use a find in update. This takes a long time to do. It's kind of like you can think of it more like kind of like an array list or a linked list, where you have to go through every single object and find the one with the tag. And if you potentially have hundreds or thousands of objects in your scene, that can be a big time something that happens that takes a lot of time, especially if you do it every frame. Imagine having to search through thousands of objects every single frame. So doing it once on awake is okay most of the time. There's a profiler built in where you can check and see how long this is actually taking. If it starts to take too long, so you have thousands or tens of thousands of objects and now you have to search through them in awake, that might be a time sink as well. So for a smaller game like this is okay. This will work. Just don't do it in update. For larger games, you might have to find another way. Okay, Andy, let's go over to Spawn Manager here. So the main sort of difference here is I put the boss prefab. I have a place for that, so we can drag that in a little bit later, drag that into the inspector a little bit later. The factory is set up with that, and then I just have a thing that increments the wave here. This will most likely spawn 2. I think I have it set to 2 enemies per wave, so this will most likely spawn 2 bosses on that boss wave, but yeah, that's something we need some extra logic for. Yes, yeah. So I made it private. I mean, you can make it public if you want to, if you like that better. But just there's a couple of options if you want to follow your sort of encapsulation / abstraction. You can use serialized field along with private rather than public. Okay, so in update here, this is just where the state does its update thing. So I am going to comment this out until we get the state ready to go, but it's basically just, yeah. So it would be, if we had our state here, it would be state equals state dot process. So the same situation that we had for our other state machines. So again, I'm just going to leave this commented out for now, but once we create the state machine, we'll come back into this. So slide wise, here it is here, and I looks like I did have the correct one in here. So game object, find game object with tag, patrol points, get components in children, transform setting to our patrol points. So if you want to grab those dynamically based on a level, maybe each level is a different scene and each scene has a different set of patrol points, this is definitely the way you want to go for it, because no matter which scene the boss spawns into, this will grab the correct patrol points for the boss to use. And then, of course, our state process. So I just have a couple pop-ups here. So we set the patrol state at the beginning and set up the patrol points properly, and then we process that boss state every single frame. Basically, we're checking, is the boss at half health? No, then continue doing its patrol. If the boss gets to be less than or equal to half health, then we're going to switch states over to the chase. Okay, this is all the movement related things. Some of this is the same as with our other enemies, but I have two different types of. I guess our chase movement is just a regular movement. I have a get patrol. Yeah. Our chase movement's a regular movement. Our patrol movement is slightly different, and then I have our get movement. This is the one that's overridden. So let me circle some of that here. So this is the one that's overridden. So this is the one that we need for overridden. The move amount is set here. So remember, move amount is what we actually move. And typically we're going to get that from the AI in some way. And we do. We get AI movement, get movement. AI movement, get movement. It just depends on what we're targeting. For the chase, this should be the player. For the patrol, this should be the patrol point. I'll say point. So this is just some extra code to make sure we're targeting the player or we're targeting the point. And then in our get movement override here, our sort of overall override get movement, then we'll use the capability, we'll use the knowledge that our state appears to change type. And we'll use that to determine which one of these movements to get. So as we go through and code this, I'll talk about those again. And I have a few pop-ups in this one as well, in this slide as well, that we'll talk about too. So I'm still in the boss enemy. Still in the boss enemy. We'll leave update here and we'll just go down a little bit. And we'll do the public void get chase movement. Need to adjust something here. Okay. All right, so we always want to get this base dot move amount because that's our actual movement. For the chase, this is easy. It's the exact same as the melee or the ranged enemy. So we just need to do our AI movement dot get movement. And we'll say target dot transform. Now, remember what target is. Target is something that we set when we spawn. Set target. That's the player. So by using the target here, we know that this is the player. And then we'll have whatever movement speed. So if we call chase movement, this get chase movement, then our move amount will be based on the AI that we put in, targeting the player, the AI component we have, targeting the player at whatever our movement speed is set to. And that's it for the chase, because it's almost identical to the other ones. The get patrol movement needs a little bit more logic to it. So if new point, so if we need a new point, and we do need a new point at the beginning, when the boss spawns and it's in the patrol state, it needs a new point. So if we need a new point, then we're going to set the target index to be a random.range. This isn't the system version. This is the Unity Engine version. So you can do this as well. You can put Unity Engine in front of it if you want to be explicit and specify it. It should use the Unity Engine one sort of automatically, but if you're finding an issue with it, you might want to throw Unity Engine in there. And we want to go from 1. So take a look at what it says. Returns a random float. In this case, a random float. We're going to put ints in here. So if I put like 1 like this, here's the integer version. Returns a random integer number between min, inclusive, so that's my first argument, and max, exclusive. So I'm going to start with 1. And then I'll go to patrol points dot length. Okay, comment in here. Why start with 1? Patrol points contains the parents and children transform. The first element in that patrol points array is the parent transform. The rest of them are the children. So I want to skip that first one and I just want to go for basically element 1 to the length, which the length is excluded. So this is one of those little quirks that you just have to remember. If you do a get components in children, it's not just the children. It will get those components in the parent if they exist in the parent as well. So it's one of those little Unity quirks that most likely you'll have an issue with, which I did the first time I had to do this. I did have an issue where I was like, why is it? It's just this weird extra thing that's happening. But yeah, that's just because it gets the parent too. And then you say new points equals false because we have a point now because that's our target index. So we have the index, we know which point we're moving to. So then I can just say that I can grab that transform. So transform, just call it T, equals patrol points, target index. So I'm grabbing that transform. And then I'm saying base dot move amount equals AI movement dot get movement, T, and movement speed. This is almost there. It's almost all the code we need. We just need a way to determine if we need another point. If we need to basically turn the new point back to true again, that we need to get another point. So if for whatever reason our base dot move amount, if that is vector2.0, so in other words, if we don't move this frame, then we've gotten within the range of our radius. Remember what our AI movement does. It moves to within the radius and then it stops and it just gives you back vector.0. So if we got back vector.0, then we're close enough to the patrol point, or at least close enough to how we decided was close enough with our radius, that we're close enough to the patrol point. So now the next frame, we're going to set this to true and then get a different point. It could be the same one. The next frame we could get the same random point again, in which case we're just going to get 0 vector back, in which case we're going to set it to true again and then go through and grab another point. So it is possible that the boss might sit on a patrol point for a few frames if the random number generator is sort of unlucky. Get some sort of unlucky random number generations. But this should work fine. There's obviously more sophisticated ways to go about this. This just picks a random one. If you wanted something where it picked them in order, then I would just have a counter that incremented every time I needed to move to another point, and it would just loop through the patrol points, for example. So it would just pick the next patrol point until you got to the end, so use a mod and stuff. So it's relatively easy for you guys to figure out how to do this, not in a random way, but the random one's easy enough. Okay, now here's where the magic happens. So we're going to do a public override. So remember, we need override as a keyword if we're going to override from the base class. And this is going to be our get movement. Now, I want to remind you real quick, we're going to get rid of the base get movement because we don't need it. I'm going to remind you real quick what the ranged enemy looks like. So here's our overridden ranged enemy movement. So it's just this. It's just the piece that we already wrote a couple of different ways in our boss. It's just this. It's just the AI movement.get movement and then whatever you're targeting. So for our boss, we do that too, but it's separated into 2 different versions of it, a chase and a patrol movement. So we need to determine which one of those we call. If for some reason our target is null, so there's no player for some reason, it could be an error, could be something you use to your advantage later on, then okay, it turns out we will be using base.get movement. This just gives us a vector.0. And we can just return straight from that. We don't have to worry about anything else. If the target's null, then we're just done. Base.get movement is just right here. Move amount equals vector2.0. So we're just not going to move if there's no target for us to move toward. That doesn't include the patrol. That's just if there's no player. Remember, the target is the player in this case. If we do have a target, if the player is a target, so the player exists and we sort of know where it is, then let's check our state. So this is where we'll have another state thing here. And it's not the class state, it's just the actual state. And this is what we're going to add. We'll add this in next, so I'm going to type it in here. And we're going to use get type. And you can use a double equals here. And then we can say type of patrol. Now your autocomplete might change these because we don't have these things existing yet. But hopefully you sort of get the idea here. If the state is a patrol, then we're going to call get patrol movement. And we could probably use an else if here. We could use an else if we wanted to as well, but I am going to check them both. If this is chase, then we're going to call the chase movement. And that's it. So we're going to use that fact that the state object appears to change type. And we're going to use that knowledge to know which one of our movement functions we need to call. We do need to override one more function. Yes, I think so. I don't know. Maybe it's in the enemy thing already, but we'll override it anyway. It's the one for getting damage. It's not going to be relevant for stuff that we're going to be doing here, but it should be fine. We'll just call this. It's not going to be super relevant because we're not going to worry too much about the damage stuff. But for taking damage, we just call the base taking damage. So that's the idea for the boss movement. We still need a state machine, but this is how we're going to determine whether we do patrol or chase and what happens when we're in patrol or chase. Now, this probably isn't the ideal way to do it, because if I want to add another state, then I need to go mess around with get movement, potentially write some other functions in the boss class. So it might not be the best way to do this. You could write different AI to do different things. So you could write some additional AI functions or additional AI classes so you could have a chase AI and a patrol AI and a few of those, and just swap the AI out depending on what the state is. That is a perfectly reasonable thing to do, and probably will end up with a little bit less code, at least in the boss enemy. But this is one way that you can do it. So if you want to, see if you can mess around with the other method where you have more AI types and swap them out when you need to change state. That would be a perfectly reasonable way to do this as well. Okay, so that's almost all the boss. Obviously, we have a few things that need to be uncommented so that we can write the actual state machine. So we definitely need to do that. Any questions about that boss class, or the boss class stuff that we just wrote? All right, so for the pop-ups here, I know it sort of seems like a lot of code, but sort of writing it and going over it, it's not too bad. So the movement is going to depend on the state. So which one of these movement functions we call to get our movement does depend on the state. And to determine that, we're checking the state object and determining which type it is to determine which one to call. Again, maybe not the best way to do it. But it is one of the options for doing this. If I had tons of states, if I had tons of potential boss states, this could start getting a little bit unwieldy in terms of what I need to add here. So then, switching over to something that might work a little better, like a bunch of different AI classes that you can just swap out when you need to, might be a better way to do it. Okay, so for the state machine, we're just going to have two states. And I'm actually going to take our state machine that we already have, and I'm going to make a copy of that. So I'm basically just going to copy and paste everything into a new boss state class. And I'm just going to make a few changes to it. So I basically just want to strip that one down, strip that current state machine down, and then turn it into this boss state machine. So there'll be some editing of stuff and making sure that everything's all named correctly and all of that. Might not be the ideal thing to do. Might be worth having just but you could probably make a generic out of this and then make it a lot easier on yourself by just coding up a generic or something. But we're going to go ahead and actually change the names on things. Basically, just copy and paste. One of the things that I say, especially in like CS1, CS2, is if you find yourself copying and pasting a lot of code, then there's probably a better way to do it. So that does, of course, still apply here for sure. So here's my whole state file that includes all the classes there. So I'm just going to copy this, and I'm going to create a new script. This will be, I'm going to call it boss state. And remember that these aren't mono behaviors, so we can't attach them to objects. That is something that I encourage you to mess around with. See if you can make one that works well for mono behavior as well. And I'm going to delete actually just everything and paste this in. I think I had one extra that I missed. And this is boss state. All right, we'll have two states. We're going to have patrol and chase. We still want the game manager. We still want all of the like next state and stage and name and all that stuff. The constructor here is boss state. To get that working correctly, I'm also going to have a reference, a protected reference to boss, boss enemy. Remember how when in our boss enemy here in the awake, we said new patrol this? That's why we need a reference to boss. Go back to boss state. So that's why I want a reference to boss, because we're sending in a boss enemy into the constructor. We have a reference to the game manager. The boss state needs to take the boss constructor needs to take a boss enemy called boss, and then I'll set it here. This.boss equals boss. So that's the beginning of this. The rest of the stuff in the sort of basic sort of boss state class is correct with the exception of this boss state for process. And next state needs to be boss state. So that's one of the things that you just have to do if you do this copying and pasting thing. You're going to have to go through each one and make sure that they are correct and they have the correct names and all that stuff in them. I'm going to delete the game over, and I don't know if I have another one here. No. Okay. So I'm going to take this one here. I'm going to name this one patrol. And this is a boss state. So then patrol needs to take in a boss enemy called boss, and I send in boss here. State here is patrol. And I'm just going to clear out update here. So a few things to change related to the constructor and the class, but that's it. And yeah, so this is how they do the constructor chaining. So instead of requiring base, instead of requiring something like super or base down here, they just do it with a semicolon and the base here. Yep. All right, so that's it for patrol. So we can take this class and we can do the chase with this one. So this is chase. And the state here, the constructor name will be chase. And the state will be chase. So this can be a little tedious if you have a lot of states or something. That's why I mentioned that it could be worth if you can come up with or potentially find somewhere a generic sort of state machine that you can just throw the types in and everything works. That could be quite useful. Or you can make your own. So there's a lot of options there for that. Back in the slides, we say that we need a reference to the boss so it can access variables, and we need the boss parameter and the constructor so we can actually get that boss reference. There's not a whole lot of stuff here. We're going to put some printing in here. We can't use the print function because this isn't a mono behavior, so we got to use debug.log. And we'll just have a few things here saying, all right, when we enter the state, we're going to print boss is now in patrol state. So just some debug checking. If the boss's health, this is why we need the reference to boss. If the boss.get health, which I don't think we've written yet, is less than the max health, something we'll probably need to write as well, divided by 2, then we're going to exit. So that's our trigger condition. You can trigger that any way you want to with or whatever variables you need to. And on exit, we go to the chase. So relatively easy here for our patrol state. So to patrol. So enter. We're going to do debug.log, and we'll say boss is entering patrol state. Okay, easy enough there. And then I think we're going to write a few of these functions. Semicolon. If boss.getHealth, I don't think we have that, so we'll write that in a second. If boss.getHealth is less than or equal to boss.getMaxHealth, which we'll write as well, divided by 2, then we're going to say stage equals events.exit. So we hit the exit. And when we do exit, we'll set up the next state to be a new chase state, and we need to send in the boss into the constructor. So relatively easy. Again, in update here, the main thing in update is to deal with when we actually change from patrol to chase. That's the big thing here. Remember that the actual movement itself is still handled by the game state. It's still handled by the entity action function. So I don't have to have any sort of movement calls in here. All of that's already going to be taken care of. All right, let's write the get health and get max health real quick. So for our boss enemy, let's throw that in here. Public, I think it's int. It's just get health. This, we're going to return the health. Now we'll have a public int get max health, and we're going to return the max health. If these variables were public, in principle, you could use them that way, but I think it is worth having getters and setters for all these things. Okay, so those two should be good here in a second. Yep. And really, the last one is just the chase state. There's not a whole lot going on here because the boss will stay in the chase state until it dies. So really, when we enter the chase state, I'm just going to print debug.log boss is now entering chase state. And then anything you want the boss to do, you could play a sound here. You could flash something on the screen. You could change the boss's graphic. Maybe to show the boss is enraged, it gets a red tint. Whatever you need to do with it. For example, we might have something where we want to set the boss's speed to be faster. So we'll have to write this function too, but we could have something like set movement speed and set it equal to whatever the current movement speed is. Boss.get movement speed times 2, for instance. Speed times 2. So double whatever the current movement speed is, right? So that's something that we could do at this time when we enter this state. So there's lots of things you could possibly do here. Think about this. Think about what you could do for like different types of attacks or something. Maybe you get close enough to the player. You change. You're in the chase state. You get close enough to the player. You change state into an overhead slam. And then you have an animation you need to play when you enter the state, and you have a sound you need to play, and you have whatever particle effects need to start playing at that point. So there's lots of stuff you can do here for these types of sort of behavior states. And this isn't really sort of a behavior state; it's just a movement state. But you can do these types of sort of state changes and play a lot of things and play sounds and change graphics and play animations and do whatever you need to do. So I'm gonna throw that in here. I'll throw both of these in here: the set and get movement speed into our boss enemy as well. So public, I think the movement speed is a float. Get movement speed. And we're going to return movement speed. Nope, that is an int. So I'm going to set that to an int. And then we'll have public void set speed, and take in an int. So then movement speed equals. Sure, great. We could add one that's like multiply or something, or double movement speed or something, whatever you want to do for this sort of thing. So that's our sort of change of our boss's state. So they should become, there we go. So they are up and available, and every single frame we're running process. We're checking, are we in the correct state? Once the state changes, then we're going to be calling different movement. For the chase, we just target the player. For the patrol movement, we target these different patrol points and move to them. Let's we're pretty much done with that state part. So let's put these patrol points somewhere in our screen here. I'm going to shrink the game screen down a bit and just look at these. All these points are at 0, 0, 0, and I'm going to make sure that the patrol points parent object is zeroed out. And then I'm going to move these around. Now you can't really see them here. They're kind of tough to see, and you can't see them on the screen very well. What we can do is we can of course move them by turning on the stuff up here in the upper left, like the rotation stuff, which we don't have to worry about for this one. But the movement ones, we can move them around. But it's tough to tell where they are just by looking at it. Joey, I'll go back here in just a second. But what we can do is when we're selected on one of the points, I can click on this box here. I think it looks like a 3D cube next to the name, and I can set a different sort of icon for them. And let's see, there we go. So I can set an icon for them. I wasn't quite clicking on it, and then it actually shows up in my view. So I can set these to whatever icon I want. You do have to have, if you want to see them you do have to have the gizmos on. So if you just see this, make sure you're turning the gizmos on here. So that's giving you all these sort of extra things. So if I do that with all of these, then I'll be able to see them very easily and just drag them around and sort of know where they are. So there's lots of little gizmos like this that can help you, especially with things like empty game objects where you can't quite see where they are unless you click on them. So here I can see exactly where my points are. And I know that the boss, wherever it spawns, will pick one of these random locations to move through. And you should be able to turn the gizmos on. You should be able to turn the gizmos on here as well in the game view. So you can see the gizmos in the game view, not useful for when you release the game, but useful for when you're playing it. If you see the boss going somewhere weird, then you know that maybe something is wrong with the way that you have the patrol points set up or something. So I'll keep gizmos on here. Joey, you want, here's set. Let me make sure that's boss enemy, not the bottom here. So yeah, so I just have it setting just taking an amount and setting it equal to that amount. That's why in the boss state, that's why I do this. I say set movement speed, and then I get the movement speed and multiply that by 2. All right, so I'm not 100% confident that this is going to work after adding all that code, but there's no errors popping up in the console. No, okay. So spoke a bit too soon. I don't think I added the boss in here yet. So let's mess around with that prefab a little bit. So the boss prefab. So we got these guys in here. In my manager, I do need to add the boss prefab in here. So the boss prefab does show up there. I don't know if that's what it wanted. Oh, because we start at wave 0, that is divisible by 3. So the first thing that spawns is actually going to be a boss. At least that's my assumption here. There we go. So we got 2 bosses here. They should be moving. If we look in here, they should be moving to the patrol points. And they get somewhat close, and then they pick another patrol point, and they move to it. And then, of course, I'm getting other enemies spawning in here as well. Now, if I take one of these guys, and let me change something in my manager here. Let's have enemies per wave be 1, and the time between spawns be like 20 seconds. So that way we're going to get one boss, just to test it. We're going to get one boss, and should be moving between the patrol points. So that's exactly what we see. It sort of moves in. It might slow down a little bit too much, so we might need to change change something on the boss prefab here for the time to target. Maybe we want that to be like 0.1, so it moves at full speed most of the way to the target. So and these are just little things that you want to change or that you could change. It takes a little bit of getting used to the AI and how the arrive movement works as to what you need to change to get what you want. But you can see that it's sort of bouncing back and forth between some things here. It's just getting some of these random ones. So at some point, it'll move up to this one. And you can change the radius to be smaller, for instance, if you want to. Now, what I'm going to do is, and we got a ranged enemy spawn here. In the boss in the hierarchy, so not the prefab, but the one in the hierarchy, its max health is 10. So let's drop this down. I'm going to change this value to 1. I press enter. And that might not do it for us here. That's right. That is the max health. We don't have access to the health, do we? So the max health was 10, but we don't have access to the health. Here you can see. Pause this here. We're gonna. I'll make the actual health public, so that we can change the actual health. But notice the size of the patrol points. It's 4, because it has the patrol points transform, the parent, and then the 3 points. That's why we only do 3. That's why we start from 1 with a random number. So just a little thing that might not be sort of obvious when you're first using some of these functions. Let's make the. I'm gonna go ahead and stop the game here. Let's make the health public, so the actual current health, not just the max health, which should be probably in the enemy script here. And the health, it's just protected. So I'm going to make this public, so that it's in the inspector. Just an easy way to do that, just so we can test that state transition. And Nathan, here is the boss enemy, and here is the get movement functions. As a back in Unity, well, let's compile. We should have access to the actual health of the enemy now. So the boss will spawn, and if we look at the boss clone, here we'll see that the health is 10, the max health is 10. So if I reduce this down to, say, 4, notice how it immediately came after me. If I set it back to 10, it doesn't do anything now, because we don't have a way to go back from chase to patrol. But as soon as I change that to 4, as soon as that went down to the sort of appropriate value to trigger the change, now I think my player's actually stuck in the hitbox of the boss. As soon as we do that, let me move my character sort of over here in the corner, and we click on the actual boss that spawned, and we change its health to 4. Now you see it's in the chase mode and it's moving faster. So that's the idea of this sort of movement / boss behavior state machine, and it really wasn't that tough to do. The boss state machine is very simple. We just took our base state machine and made sure that whatever condition was, we changed to a new state. The sort of tough part, the part with a lot of code, is our different sort of movement stuff here and our get movement, but that you could actually handle most of that with different AI components as well. So the nice thing about this being a mostly sort of modular components with the AI and with the state machine, you can easily make that sort of modular in the inspector, or modular kind of like what we've done here with just an object representing the state machine, is that if you want to make a different type of enemy, or a different type of boss, or add more behaviors to a boss, or different movement types to a boss, it's relatively easy to do. You just add a new class, like a state, and then or an AI movement behavior, and then you're good to go. You just swap it out or transition to it, and your boss is going to do something different. So there's a lot of cool stuff here, and hopefully this has at least shown um, some of what you can do with some of these patterns and some of these ideas that we've talked about in this particular game, and to a lesser extent in the previous ones. Most likely, that's probably where we're going to mostly stop. I may show. We're just about out of time today. I may show either next time or Tuesday. I may show how to change the state machines so that we have a fixed update, because I think that is useful. Everything right now is sort of happening in update and Unity's update method, and we probably want a fixed update in here so we can call that during the fixed update in Unity. So I think I might show that as well, but that's mostly where we're going to stop with this because we only got 2 lectures left. I want to show a little bit with the tile editor next time as well. So maybe next time will be some tile map editor stuff and the changing the state machine so that it actually uses fixed update rather than update for the physics movement. And then potentially something else. One thing we haven't covered that is very important, especially in 3D, but you can use it in 2D. Plenty of uses in 2D as well, is Raycast. So Raycasts are super useful, and that could be something that we do the sort of following Tuesday. For your final project, I mentioned some of that stuff at the beginning. We will be here during the regular finals time. I want everyone to have to basically give a short presentation about their game. So we'll talk about that next time. So you'll have sort of a few days to throw a few slides together, throw a demo together, just talk about some of the interesting stuff that you did, or new things that you found, or if you made a cool shader or something in Shader Graph, how you did that. That's just sort of sharing with the rest of the class that on sort of different things that you did. So expect that as well. Sort of keep that in mind as you're working on the game. But we'll talk a little bit more about that next time. Okay, so that's all for today. So I will see you guys on Thursday for a little bit more and a little bit more Specter and tile map stuff. So have a good rest of your day. I'll see you then.
Thanks, Professor. Have a good one.
So, yeah.